Hello everyone. Let's start with the question practice session for NEET 2025. Today we have taken the topic solution part 1. The subtopic that we are going to cover is the concentration of the solution like molarity, molality, mole fraction, normality, all those kind of questions we will see today. The questions chosen for today's discussion is either NEET PYQ or questions similar to the NEET PYQs. Let's start. How many grams of CH3OH should be added to water to prepare 150 ml solution of 2 molarity CH3OH? Right? So finally what they are asking in the question, you have to prepare a solution. That solution's volume should be how much? 150 ml and molarity of the solution should be 2m. 2m is the molarity. How you are preparing? You are adding CH3OH in water and you are preparing this particular solution, right? Now they told that in doing so, how much amount of this solute you need to add to water so that this particular strength and this particular volume you can achieve. This is the question. Now let's see how to do. Simply we'll use the molarity formula, that is molarity is equal to given mass of the solute divided by molecular mass of the solute into 1000 by volume of the solution in ml. If in liter, so no need to divide by 1000 because we have taken in ml, so divided with 1000. The strength of the solution is given, that is 2 molar. Given mass, we need to find it out. Molecular mass of CH3OH. So solute is CH3OH. Carbon's mass is how much? 12. Hydrogen's mass 1, but 4 hydrogens are there. Oxygen's mass is 16. So this in total, how much we are getting? 32. Right? So 32 is the molecular mass of the solute which is taken. Let's put 32 into 1000 divided by the volume. What is the volume given to us? How much we need to prepare? 150. 0, 0 cancels out. So let's find the mass will be is equal to 2 into 32 into 15 divided by 100. 15 into 2, 30 into 32 divided by 100. So this 0, 0 cancels out. Okay, 326, 339 by 10. So how much we are getting? 9.6. So 9.6 gram will be the mass of the solute that we need to add to water to maintain the strength of 2 molar and maintain the volume of 150 ml. So my option will be C, 9.6. Next one. Calculate the quantity of sodium carbonate. Again you need to calculate quantity, that is mass of the sodium carbonate required to prepare. The volume of the solution is given to you and the molarity of the solution is given to you. Same like the previous question. Molarity is equal to what? Given mass of the solute by molecular mass of the solute into 1000 by volume of the solution in ml. Done. Now what is the molarity you need to maintain? 0.1 is the strength. Given mass I need to find out molecular mass. So the solute taken here is nothing but sodium carbonate, Na2CO3, sodium carbonate. Mass of sodium is 23. How many sodiums are there? 2. Plus mass of carbon is 12. Plus mass of oxygen is 16. How many oxygens are there? 3. Okay, this is the simple calculation. So 23 into 2 is 46 plus 12 plus 16 into 3 is 48. Now how much it is becoming? 16, 1. So this is 106. 106 is the molecular mass of the solute, that is sodium carbonate. Let's put it 106 into 1000 divided by what volume we need to maintain? 250 ml. Okay, 25, 4. So given mass, that is the mass we need to calculate is 0.1 into 106 divided by 4. This much it is coming. Now 4, 2 is 8, so it becomes 26. So if I put 6, so it will be 5. So how much it is becoming? 0.1 into 26.5. So it will become 2.65 gram. 2.65 gram of sodium carbonate has to be taken in order to maintain the strength 0.1 molar of the solution and maintain the volume 250 ml. So my option will be 2.65, that is option A. Done. Next one. Suppose 5 gram of CH3COH is dissolved in 1 liter of ethanol. The solute is CH3COH and the solvent is ethanol. Assume no reaction between them. So there is no reaction between the solute and solvent. Calculate the molality. So now we need to calculate molality of the resulting solution if the density of the ethanol, again one more thing, density of the ethanol is also given to us, that is 0.789 gram per liter. Right? Fine. Molality. What is molality? Molality is equal to mole of the solute, that is given mass of the solute by molecular mass of the solute into 1000 by mass of solvent in gram. If it is in kg, then no need to divide with 1000. Simple. Now what were the things given to us here? Mass of the solute is given. We know the molecular mass of the solute, we can calculate out. Okay, but mass of the solvent is not given directly. Mass of the solvent is not given directly. Density is given and volume is given. We know a formula that density is equal to mass per unit volume. We need mass. Mass is not given directly. Okay, so what is the mass? Mass is equal to density. What is density? 0.789 into what is the volume? 1 liter. I'll convert it into ml because density is in ml. So I'll convert it into ml. So it will be 1000. So 1000, this is ml and this is what? Gram per ml. Right? So finally what mass I am getting? 789 gram. This is the mass I am going to get of the solvent. What is the molecular mass of CH3COH? So carbon is 12. How many carbons are there? 2. Hydrogen is 1. Mass, how many hydrogens are there? 4. Plus oxygen is 16. How many oxygens are there? 2. So 12 into 2 is 24 plus 4 plus 32. How much? 60. So molecular mass of the solute will be 60. Let's put into the formula and try to find out the molality. Given mass of the solute is 5 gram. Molecular mass just now we found 60 into 1000 by mass of the solvent is 789. Right? So if I cancel it out in this way, finally how much I am getting here? 500. 1 second, it looks like 8. So how much I am getting here? 500 divided by 6 into 789. So this will be 4, 3, 7 and 47. Right? So after calculation, finally I am going to get it 0.1056 molal. This will be the molality of the solution which we are preparing by dissolving 5 gram of the solute in ethanol. So my answer 0.1056. Option will be C. Done. Next one. A 5.2 molal aqueous solution of methyl alcohol supplied. What is the mole fraction? So we need to calculate what? Mole fraction of methyl alcohol in the solution. This is aqueous solution. What is methyl alcohol? Methyl alcohol is CH3OH. This is the solute. Aqueous solution means what is the solvent? Water. With this we have prepared a solution. We need to calculate the mole fraction of the solute for this. So they have given 5.2 molal aqueous solution. What does this mean? This means that 5.2 moles of methanol is present in how much amount? 1 kg, that is 1000 gram of the solvent. What is our solvent? Water. So I can write this statement. Okay, if I remove this part, what I can write with the given statement that 5.2 molal, the meaning of this is 5.2 moles of the solute is present in 1 kg or 1000 gram of the solvent, which is water. This much we can understand. So from this information, what do I get? That mole of the solute. What is the solute? CH3OH is how much? Just now we have written 5.2. Right? And also from here, can I calculate mole of the solvent, that is water? What is mole? Mole is given mass by molecular mass. What is the given mass of water? 1000 gram. What is the molecular mass of water? 16 plus 2, 18. After calculation, how much we are getting? 55.55. Okay. So this is the 5.2 is the mole for the solute. 55.55 is the mole for the solvent. We need to find mole fraction for the solute, CH3OH. So it is equal to what? Mole of the solute divided by the total mole, that is mole of the solute plus mole of the solvent. This is the formula for mole fraction of solute. Let's put into the formula. This is 5.2 divided by 5.2 plus 55.55. Okay, how much we are getting? 5.2 divided by, this is 5, 6, 7, so 60.75, right? 60.75. After calculation, we'll be getting 0.0855. This is the mole fraction for the solute. So 0.085 or 86. B will be the answer. We need to decode this part. 0.2 molal. 0.2 molal meaning is, sorry, 5.2 molal. 5.2 molal meaning is 5.2 moles of the solute is present in 1 kg of the solvent, that is water. From this we have decoded and find out the mole fraction of the solute. Clear? Next one. In 1 molal solution, what is given to us? Molarity of the solution is 1 molal. Molality of the solution that contains 0.5 moles of the solute. Moles of the solute is also given. Molality of the solution is also given. Related to the solvent, you need to find information, right? So what is molality? Molality is moles of solute by mass of solvent in kg. This is molality. What molality is given? It is 1 molal. Moles of the solute is also given to you 0.5. 1 second. 5 looks like 8. Okay, so 0.5. Then divided by mass of the solvent. We don't know the mass of the solvent. Let's put this mass. Let's take the mass into grams. So we'll divide the mass by 1000. Done. So what is the mass? Mass in gram will be equal to what? 0.5 into 1000. How much it is coming? 500 gram. So 500 gram is the mass of the solvent. So option will be B, 500 for 5. Okay, next one. How many grams of dibasic acid? Again, you need to find the given mass. How many grams of dibasic acid? The dibasic acid's molecular weight is given to you is 200. Should be present in volume of the solution is given 100 ml of the aqueous solution to give us strength. Strength is given in terms of normality 0.1 normal. So how many grams of dibasic acid is present in a solution so that the strength of the solution becomes 0.1 normal and the volume of that solution is 100 ml? This is the question, right? Fine. So what is normality? Normality is given mass of the solute by equivalent mass of the solute into 1000 by volume of the solution in ml. So because I have taken in ml, that's why divided by 1000. Then instead of writing equivalent mass, we can also write it in this way. Normality is equal to given mass. What is equivalent mass? Equivalent mass is molecular mass divided by the n factor into 1000 by volume. This also I can write. Equivalent mass is molecular mass divided by the n factor. Normality given to us in the question is 0.1 normal. Given mass we need to find out. Molecular mass is given to us, that is 200. Okay. N factor, it is a dibasic acid. Di means 2. So H positive, 2H positive, protonation will be 2. So N factor will be 2 into 1000 by what is the volume given? 100. If we cancel out, okay, if we cancel out, so how much we are getting here? 10. So my given mass will be equal to 0.1 into 10, that is 1 gram. So 1 gram should be the mass of the dibasic acid that we need to add to the solvent in order to make the solution 100 ml and strength of the solution should be 0.1 normal. So my option will be C, 1 gram. Done. Next one. What is the molarity of NH3 solution? You need to find the molarity of NH3 solution. If the density is given to you, which contains 12% of NH3 by weight. So 12% of NH3 by weight is given to us. Okay, what we need to find? Molarity. We know what is molarity. Molarity is given mass of the solute by molecular mass of the solute into 1000 by volume of the solution in ml. Right, this is the formula. Now given mass, okay, we have to decode it from this particular thing, that 12%. What do you mean by 12% NH3 by weight? This means that 12 gram of the solute, that is NH3, is present in 100 gram of solution. Okay, the meaning of this is 12 gram of the NH3 is present in 100 gram of the solution. So from here, what do we have? We have the given mass, that is NH3 is 12 gram. What is the molecular mass of NH3? What is the molecular mass of NH3? So NH3, N is 14, hydrogen is 1. How many hydrogens are there? 3. It will be 17. 17 is the molecular mass of the solute into 1000 divided by volume is not given directly of the solution. Okay, we need to find it out. We also know that density is equal to mass per unit volume. Volume is not given to us. We'll find out volume. So volume is equal to mass. What is the mass of the solution? 100 gram. What is the density of the solution? Density is 0.95 gram per ml. This is given to us in the question. Right? So 1000 divided by 0.95, gram cancels out. If we calculate it out, it will come 105.26 ml. This is the volume. So let's put the volume here in the formula, 105.26. Done. So how much we are getting? This is 12,000 divided by 1789.42. If we further calculate this, this will come as 6.70 molar. So this is the molarity coming out finally 6.70. So 6.70 means my option will be A. 6.7 molar will be the molarity of NH3 solution, which is 12% NH3 by mass. Okay, so this kind of things we need to decode and we need to find it out. This kind of questions already we have seen in the last part also. Whenever percentage wise they give, make it out and then we'll put the values according to that. So 12 gram will be the given mass, 100 gram will be the mass of the solution, density was given, we have calculated out the volume. So in that way substitution we are getting the answer. Next one, the molarity of pure water is, you need to calculate what? Molarity of the pure water. Only one thing is given to us, density of the pure water is given to us. So density, what is the density given? 1 gram per ml. This is the density of the pure water given. This I can also write as 1 kg per liter. 1 gram per ml I can also write as 1 kg per liter. This 1 kg per liter means what? 1 kg, that is 1000 gram of, 1 second, 1 kg that is 1000 gram of. Now pure water means solute is also water, solvent is also water. So 1000 gram of water is present in 1 liter of water. 1000 gram of water is present in 1 liter of water. This is the meaning, because pure water, solvent is also water, solute is also water. Right? We need to find what? Molarity for this. What is molarity? Molarity is given mass of solute by molecular mass of solute into 1000 by volume in ml. Okay, this is molarity. This is the molarity. Now what is the given mass? How much? 1000 because 1 kg, so 1000 gram. Molecular mass of water, you know it is 18. How? H2O, 2 plus oxygen is 16, so it will be 18. Molecular mass of water is 18 into, if I take the volume in liter instead of ml, so no need to divide by 1000. So I am taking it as 1 liter. Okay, so molarity I am taking it as liter, or if you have confusion, I'll write the thing in this way. So it is volume in liter. So I have taken the volume in liter. So 1 liter. Done. 1000 divided by 18 is 55.55 molar. So molarity for this is 55.55 m. Option will be C. Okay. Again, how did we find out? By decoding this thing. 1 kg per liter. This is a pure water. Pure water means water is the solute, water only is the solvent. So 1 kg, that is 1000 gram of water is present in 1 liter of water. With this we have substituted and find out the molarity. Fine. Next one. How much water is needed to dilute? So you need to calculate how much water, right? This is the calculation you have to do to dilute 10 ml of 10 normal HCl to make it exactly decinormal. So what they're asking, you have a solution of HCl which is volume is 10 ml and normality is 10 normal. This is the HCl solution you are having. To this, you want to add some water. You want to add what? Water, so that you can dilute it. Addition of water means what? You are diluting it. To dilute it to what? How much? You want to dilute it to how much normal? Decinormal. What is decinormal meaning? 1 by 10 is the strength of the new solution after dilution. So you had a stock solution. You had a stock solution of how much? 10 normality. You are diluting the stock solution and making it, reducing the normality to 1 by 10. So how much water you need to add to dilute the stock solution and reduce the normality from 10 to 1 by 10? This is the question. Fine? Okay. Can I use, see what other things we are having here? I have NV, here I have N. Can I use the formula? N1V1 is equal to N2V2. Can I use this formula? Okay, what is my N1 in the stock solution? 10 into, what is my V1 for the stock solution? 10 is equal to N2 is 1 by 10. We don't have volume of the new diluted HCl solution. This is also HCl, diluted HCl. We don't have, right? So what is the V2? V2 is equal to 10 into 10 into 10, that is 1000 ml. This is V2. V2 means the volume of the diluted solution, total volume of the diluted solution. Total volume is what? The original volume plus the water. The total volume is nothing but the original volume plus water. Original already 10 ml was present. Okay. Now understand this one. This has become how much? V2. This V2 has become how much? 1000 ml. Now this 1000 ml is a combination of this 10 ml also. No? 10 ml is also there, plus you have added water. So H2O added, the water that we are going to add is equal to 1000 minus what was present originally, that is 10, this much. So it should be 990 ml of water you need to add extra to dilute the 10 ml HCl solution to reduce the normality from 10 normal to 1 by 10 normal. This much amount of extra water you need to add to the 10 ml of 10 normal solution, HCl solution, to reduce its normality to 1 by 10. Okay, so my answer is 990 ml, which is the option A. Option A will be the answer for 9. Done. Next one. What volume of water? Again, you need to calculate volume of water. What volume of water? Which must be the volume of water that must be added to a mixture of, okay, you have a mixture of 350 centimeter cube of 6 molar HCl and 650 ml of 3 molar HCl to get a resulting solution of 3 molar concentration is. Now understand the question here, what they are telling. You are mixing two HCl strength solutions. Okay, how? See. You have one HCl. The strength of that HCl solution is 6 molar. Volume is 350 centimeter cube. I can also write as ml. Right? I have another HCl whose strength is 3 molar. Volume is 650 ml. Okay, I'm mixing them and putting it into a new beaker. Fine, I'm putting them into a new beaker. Putting it into a new beaker. What I have done? this one I have put here, this one also I have put here, and I made a new HCl solution. This is also HCl, but they are saying I want to maintain the strength as 3 molar. I have to maintain the strength as 3 molar of this new HCl solution. So I need to add some extra water here to maintain the strength of 3 molar. How much water should I add in extra so that I can maintain the strength after mixing the 2 other HCl solution, and I can maintain the strength to 3 molar. Done. What I can use here is, because 2 solutions are mixed together, can I use M1V1 plus 2 are mixed, M2V2, these 2 are mixed to give you what? M3V3. This is the new solution which has been prepared. M1, what is the molarity of the stock solution? First stock solution 6 into volume 350 plus molarity of the second one is 3 into volume is 650 is equal to molarity of the new solution that we are preparing is 3, and volume we don't know because we need to add water, so we don't know the volume. Done. How much we are getting here? 0, 0, 18, 21 plus 0 here 5, so 19, okay, is equal to 3 into V3. So what will be my V3? V3 is equal to 4050 divided by 3. Finally, how much V3 I am going to get? 1350 ml. This is the V3, that is the volume of the third solution whose strength is 3 molar we are going to get. Now this volume is actually the volume that was already present. Which was already present? 350 ml, 650 ml plus the additional water. So to find the additional water, what I'll do? So water added is equal to the total volume, that is 1350, minus the previous volumes that were present, that is 350 plus 650 ml. Okay, how much? 1350 minus 1000, that is 350 ml of additional water I need to add to the mixture so that I can maintain the strength of 3 molar in the new solution. Fine. So my answer will be 350. Which option? D. D will be the option for 10th. Done. Next one. The mole fraction of the solute. You need to calculate what? Mole fraction of solute in 1 molar aqueous solution. 1 molar. This kind of question already previously we have done one. Right? 1 molar aqueous solution. What is the meaning of 1 molar? 1 molar means 1 mole of solute is present in, for molality it is 1 kg. So 1 kg or 1000 gram of solvent. Aqueous solution means what is the solvent? Water is the solvent, right? Now from here, what do I get? Mole of the solute is what? 1 molar, so 1 mole. Mole of the solvent. Solvent is water. Okay. Given mass. What is the given mass? 1000. What is the molecular mass of water? 18. How much we are going to get? 55.55. Then we need to calculate mole fraction of the solute. So mole fraction of the solute is equal to what? Mole of solute divided by mole of solute plus mole of water. Right? Let's substitute everything and find out. Mole of solute is 1. 1 plus mole of water 55.55. How much? 1 by 56.55. This much I am getting. So finally my answer will be 0.017. Okay, 0.017. So this much mole. Can you see this in option 0.017? This is 1/8 is there, so we'll put as B. B is the answer for 11th. So whenever this kind of things are given, no, learn to decode these things. Okay. Next one. How many grams of concentrated HNO3 solution should be used to prepare? You need to calculate the number of grams of HNO3 solution. Okay. Used to prepare the volume of the new solution is given 250 ml of strength is 2 molar HNO3. The concentrated acid is 70% of HNO3. Again you have that 70% thing. Let's understand this. You have to prepare a new solution. You have to prepare a solution. Let's take a beaker. We are going to prepare solution. Right? What solution you need to prepare? HNO3 solution. What is the strength of the solution? 2.00 molarity, molar. What is the volume of this new solution that you are preparing is 250 ml. These are the informations given that you are preparing a solution of 2 molar. Okay. And the volume of that solution is 250 ml. How you are preparing? You have a stock solution. Suppose you have a bottle. So you have a stock solution. That stock solution of HNO3 is actually 70% HNO3. The strength is 70% HNO3. From here you are taking some amount, how much gram you are going to take from here, so that you can prepare this particular solution. From stock solution, how much gram you are going to take, so that you can prepare the solution that whose strength is 2 molar and the volume is 250 ml. This we need to find out. So how much gram I need to take out? First I need to find out how much gram is present in the solution that I am going to prepare. So what is the molarity? Molarity is nothing but it is given mass by molecular mass into 1000 by volume of solution in ml. This is molarity formula. Okay. Given to us that we need to prepare what? 2 molar solution. Okay. Given mass I need to find out now how much I'll take. Okay. Given mass I don't know. Molecular mass HNO3. Let's calculate molecular mass for HNO3. Hydrogen is how much? 1. Nitrogen how much? 14. Oxygen how much? 16 into 3. Yes or no? This is the calculation. So it is equal to what? 15 plus 16 into 3 is 48. So how much we are going to get? 63. Okay. Let's put here. That is 63 is the molecular mass into 1000. What is the volume they are asking us to prepare? 250 ml. Okay, 25 4s are 100. So the mass which is present in the solution is 2 into. So we'll put here what? 63. 2 into 63 divided by 4. So 2 2s are 4. How much we are going to get here? 361.5. So mass should be 31.5 gram. The mass which is present in the solution that they are asking us of 2 molar strength. Done. Now from the stock solution, let's try to calculate. 70% HNO3 means what? 70 gram HNO3 is present in how much? 100 gram solution, right? If I have to gain 31.5 gram, I don't need 70 now, I need 31.5. This much I need. 31.5 gram of HNO3 will be present in how much? 100 divided by 70 into 31.5 gram of the solution. Yes or no? Now if I cancel out 0 0 here, so how much I'll get? 315 divided by 7 gram of solution. Okay, how much? So this is 45 gram. 45 gram of the solution I need from this stock to prepare a new solution whose molarity will be 0.2 molar and the volume will be 250 ml. So how much stock solution I need to take out? I need to take out 45 gram of the stock solution. So my answer 45 gram, where it is present in C. Option C will be the answer for this. Done. This was a PYQ. Okay, this is a new section introduced. Now in this section, what we see that I want you to try these questions on your own. Okay, please take a screenshot and try the questions on your own. This question answer will be uploaded in the channel tomorrow, the answer discussion of the answer, but at least you try by yourself one time. Only 5 questions are there, try on your own. And also you know that we have a set of teachers, so if you want to clarify any other doubts or one-to-one discussion you want to do, please mail us in this particular mail ID. Okay, you can clarify your doubts with us. Thank you for joining the discussion.